Tonight, we're stepping into a subject that feels familiar, something we talk about so casually that we forget how extraordinary it truly is: the universe. But the moment you look past the comfortable idea of space and confront what it actually contains, everything changes. Suddenly you're staring into a reality so vast, so layered, so overwhelming that your sense of size and distance simply falls apart. We picture stars scattered across a night sky, maybe a galaxy or two spiraling beautifully in the dark. But that isn't scale. That's only the first brushstroke. The real universe is a hierarchy of immensity: solar systems inside galaxies, galaxies inside clusters, clusters woven into titanic filaments stretching across billions of light years. And beyond all of that lies a horizon we can never cross, set not by imagination, but by the speed of light itself. Once you begin to understand these layers, once you see how each step outward multiplies the scale of everything, the cosmos stops feeling like a backdrop. It becomes a structure, an unfathomably vast architecture where even light struggles to keep pace. Before we go any further, if you enjoy exploring the deeper, stranger side of our universe, a quick like or subscribe really helps the channel grow. Thank you. Now, take one last look at the world around you, because what comes next will make it feel smaller than ever. To understand the true scale of the universe, you must begin with an idea so deceptively simple that most people never truly internalize it. The speed of light is not just fast, it is the ultimate cosmic speed limit. Nothing outruns it, nothing overtakes it. It defines what can be known, what can be seen, and what remains forever locked behind the unreachable curtain of distance. Light travels at 299,792 kilometers per second, a number so large it feels meaningless, until you realize that even at that speed, crossing the universe is a journey measured not in seconds, but in years. And that measurement, the light year, becomes the first tool for navigating cosmic scale. A light year is the distance light travels in one full year of uninterrupted speed, nearly 10 trillion kilometers. It is a unit so gigantic that even the nearest stars sit multiple light years away. When we say Proxima Centauri is 4.24 light-years from Earth, what we really mean is this: if you could climb aboard a ship traveling at light speed, you would still spend more than 4 years racing across black, empty nothing before reaching the closest star beyond our Sun. And our own solar system, for all its planets, moons, comets, and drifting debris, is barely a bubble against that vastness. Light takes 8 minutes to reach Earth from the Sun, but nearly 5.5 hours to reach the region where the Sun's influence fades into interstellar space. Even traveling at light speed escaping the solar system is a journey measured in hours, not moments. But here is the part that truly redefines perspective. Even at the scale of the solar system, space is mostly emptiness. Planets are tiny, glowing beads suspended inside an enormous, almost perfectly hollow sphere. Our Sun, so overwhelming to us, shrinks into insignificance when we place it inside the context of distance. The spaces between planets are so immense that if the Sun were the size of a basketball, Earth would be a peppercorn about 26 meters away. Neptune would be nearly a kilometer distant. And beyond that, nothing but cold, quiet emptiness stretching outward. The human mind was never built to comprehend distances this large. We rely on metaphors, models, and analogies to reduce the incomprehensible into something we can momentarily grasp. But even those tools break apart if we push too far, because the scale of the universe is not simply big. It increases exponentially with every level we explore. Just when you think you understand it, the next layer overwhelms your intuition again. Before this journey continues into deeper cosmic waters, take a moment to ground yourself. Everything you have ever known fits inside a tiny sliver of the universe, a sliver so small it disappears the moment we step beyond it. Beyond the boundary of our solar system lies the interstellar medium, a sparse ocean of dust, gas, magnetic fields, and frozen particles drifting between stars. It is here, in the enormous voids between stellar systems, that the scale of the universe begins to reveal its second layer, the vast three-dimensional expanse filled with stars, each one separated by distances so large that it feels as though the cosmos intentionally spaces them apart. Our Sun is a faint yellow dot in a sea of hundreds of billions of other stars, all orbiting the center of the Milky Way, like drifting sparks in a colossal whirlpool. But these sparks are not tightly packed. They are spread out with astonishing distance between them. If the Sun were a grain of sand, the nearest neighboring grain would be another tiny speck located several kilometers away. That is how empty our region of the galaxy truly is. The nearest star system, Alpha Centauri, is so far that the fastest spacecraft humanity has ever launched would take tens of thousands of years to reach it. Meanwhile, light, moving at the absolute maximum speed allowed by nature, still requires over 4 years to complete the journey. Even the most generous science fiction technology would struggle against the sheer tyranny of interstellar distance. And yet, our little corner of the galaxy is unremarkable. It is an average patch within an average arm of an average spiral galaxy. Stars lie scattered in every direction, some younger than our Sun, and some ancient enough to have witnessed events long before Earth took shape. Red dwarfs, small, cool, and incredibly long-lived, make up the majority of stars, while giants and supergiants blaze brightly before quickly burning out. White dwarfs linger as fading embers of stellar history, and neutron stars lurk as tiny, warped remnants of collapsed suns. But no matter their type, all stars share one thing: separation. The spaces between them are so large that collisions are rare, gravitational interactions subtle, and light from one star takes years, sometimes centuries, to reach another. Space, at its most basic level, is structured around distance, immense, suffocating distance. The stars we see sprinkled across the night sky appear close, arranged on a velvet dome overhead. But this illusion is a trick of perspective. In reality, those stars lie at wildly different distances, some dozens of light years away, some hundreds, some thousands. Our view flattens three-dimensional cosmic architecture into a single plane. The result is a false intimacy that hides the truth. The stellar neighborhood is vast, empty, and almost entirely silent. Every point of light you see is a world unto itself, separated from every other world by gulfs so wide that even light struggles to cross them. If the solar system is a grain of sand and the stellar neighborhood is a beach, then the Milky Way is the entire coastline, stretching farther than the horizon, curving into distances so immense that every star we have ever seen becomes nothing more than a faint dot inside an incomparably larger structure. The Milky Way is a barred spiral galaxy roughly 100,000 light-years across. 100,000 years, just for light to travel from one end to the other. For comparison, anatomically modern humans have existed for about a tenth of that time. Civilization, in its entirety, is a flicker compared to the time it takes a beam of light to traverse our galactic home. Our Sun sits inside one of the Milky Way's spiral arms, the Orion Arm, about 27,000 light-years from the galactic center. That center is a place of violent beauty, a densely packed region of stars orbiting a supermassive black hole known as Sagittarius A. Around this core, stars move at tremendous speeds, completing their orbits in mere decades rather than hundreds of millions of years. The gravity is so intense that entire clusters of stars behave like sparks caught in the pull of a cosmic vortex. But most of the Milky Way is not like its center. The vast disk is filled with sweeping arms that rotate slowly, carrying billions of stars along their trajectories. Each arm is a river of light, gas, dust, and stellar nurseries, regions where gravity gathers raw material into new suns. These nurseries glow in soft pink light, illuminated by the ultraviolet radiation of the massive young stars forming within them. And even this glowing structure, magnificent as it is, conceals the true scale of the galaxy. The distances between spiral arms are measured in thousands of light-years. The thickness of the galactic disk is tens of thousands more. Traveling from one side of the Milky Way to the other would not be a journey. It would be the work of countless generations, a migration across a cosmic continent so vast that no single lifetime could witness more than the smallest fraction of it. Inside this enormous structure, stars orbit the center in a slow, stately procession. Our Sun completes one orbit every 225 million years. In the time since the dinosaurs roamed Earth, our solar system has traveled only a fraction of its path around the galaxy. We are passengers inside a titan, carried along currents of gravity we cannot feel but are bound to nonetheless. Yet what might be the most mind-bending truth is this. Despite its staggering size and population of hundreds of billions of stars, the Milky Way is just one galaxy, one among trillions. The true scale of the universe is not defined by stars or even by galaxies. It emerges when we step back yet again, widening our perspective beyond what feels even remotely fathomable. And as immense as the galaxy is, it is only the beginning. When you finally leave the Milky Way, not figuratively but in scale, something unexpected happens. You might imagine galaxies sitting close together, like stones in a riverbed, their spirals brushing edges and exchanging stars. But the universe is not arranged that way. Instead, galaxies are separated by gulfs so immense that each one becomes an island floating alone in a vast cosmic ocean. The space between them is not just empty, it is emptiness on a scale beyond anything in human experience. The Milky Way resides in a small cluster known as the local group, roughly 3 million light-years across. Our nearest large neighbor, the Andromeda Galaxy, sits more than 2 million light-years away. Even at the speed of light, the journey takes longer than the entire history of Homo sapiens. And between these galaxies stretches nearly perfect darkness, broken only by the occasional stray star or dwarf galaxy adrift between the giants. This intergalactic space is not the cold vacuum of imagination. It is colder. It is emptier. A cubic meter of space here contains fewer atoms than the emptiest laboratory vacuums ever created on Earth. No air, no dust, no planets, no remnants of solar systems torn apart. Just the thin whisper of hydrogen drifting through near-total nothingness. Most of the universe is like this. Silent expanses where nothing shines, where even gravity seems to loosen its grasp. The nearest galaxies are separated by distances so large that their light takes ages to cross the dark, and that light is distorted by expansion, stretched into redder wavelengths as the fabric of space slowly carries the galaxies apart. Even so, these galaxies are gravitationally bound, members of a small family adrift together. But once you go beyond the local group, you leave behind this quiet neighborhood and enter an arrangement far stranger and far more immense. Galaxies gather into clusters, clusters into superclusters, and superclusters into filaments that span hundreds of millions of light-years. Between them sit voids, cosmic deserts, where entire regions of the universe contain almost nothing at all. A single void can stretch hundreds of millions of light-years across. Standing inside one, if such a thing were possible, you would see so few galaxies that the sky would look nearly starless. The universe would feel hollow, as if the cosmos itself had vanished beyond the edge of sight. This is the intergalactic medium, a dark ocean so profound that galaxies become lonely islands inside it. And this emptiness, the sheer unbroken scale of it, forms the cosmic stage upon which every star, every planet, and every civilization is set. From a distance, the Milky Way seems immense, but when you step back far enough to see it as part of a larger structure, it becomes only one city in a sprawling cosmic metropolis. Galaxy clusters are the universe's most massive bound structures, containing hundreds or even thousands of galaxies, all orbiting one another within an enormous gravitational well. Our local group, for all its modest size, lies on the outskirts of a much larger system, the Virgo cluster. It is a grand assembly of galaxies roughly 50 million light-years away and several million light-years across. The Milky Way is not a resident, it is merely a distant cousin, connected to this cluster by faint gravitational threads. Inside Virgo, elliptical galaxies dozens of times larger than the Milky Way drift like ancient giants. Spiral galaxies twist through hot, X-ray emitting gas heated to millions of degrees. Dwarf galaxies swarm like cosmic insects around their massive hosts. The mass of a galaxy cluster is staggering. Most of it is not even stars or planets, but dark matter, an invisible framework of gravity holding everything together. Without dark matter, clusters would simply fly apart, too large and too chaotic to remain bound. Instead, they behave like enormous families of galaxies caught in each other's gravitational pull, swirling in slow, majestic orbits that take billions of years to complete. What makes clusters truly awe-inspiring, however, is not just their size but their density on cosmic scales. While intergalactic space is almost perfectly empty, clusters are crowded regions where galaxies can pass near one another, distort each other, or even collide. When galaxies merge, the stars within them rarely collide directly. Space is too vast even inside galaxies, but their combined gravity reshapes their structure into new, spectacular forms. Some of the largest galaxies ever observed are the products of countless mergers inside ancient clusters. In the heart of these clusters lies a dominant galaxy, a central titan swollen by billions of years of cannibalism. Its glow stretches across hundreds of thousands of light-years, fed by the remains of galaxies it has absorbed. This central giant often hosts a supermassive black hole, millions or billions of times the mass of the Sun, anchoring the cluster's core with irresistible gravitational force. Even so, galaxy clusters themselves are not the end of cosmic hierarchy. They are building blocks for something even larger, structures so immense they defy both language and imagination. To see the universe as it truly is, you must zoom out yet again. When you do, galaxy clusters stop looking like clusters at all. They become mere nodes in a web stretching across the cosmos. The farther you step back, the more the universe transforms. What once looked random suddenly reveals structure, patterns so vast they cannot be fully seen from any single vantage point. Galaxies are not scattered like seeds tossed into the wind. They arrange themselves into a grand cosmic web spanning billions of light-years, the largest structure humanity has ever discovered. This web is not literal strands, but the distribution of matter shaped by gravity over billions of years. Dark matter, silent, unseen, and dominant, forms the invisible scaffolding. Ordinary matter follows its lead, gathering where gravity is strongest and leaving behind immense voids where it is weak. The result is a tapestry woven from filaments, nodes, sheets, and empty expanses. Filaments stretch for hundreds of millions of light-years, glowing faintly with the combined starlight of the galaxies embedded within them. These filaments intersect at nodes, regions so dense that galaxy clusters form as natural consequences of cosmic gravity. Between these structures lie the voids, cavernous, lonely regions almost completely devoid of galaxies, some so vast that the Milky Way could cross them and still never reach the center. When astronomers map the universe on the largest scales, they find that it looks almost biological, as if resembling the neural network of a cosmic mind or the branching structure of a living organism. The resemblance is coincidental, but the feeling it inspires is unmistakable. The universe is organized in ways that seem almost mythic in their complexity. Yet even as the cosmic web reveals the structure of everything, it also highlights our fragility. The entire observable universe, everything we can see or detect, is only a bubble inside a far greater reality. Beyond the edge of visibility lie regions forever beyond our reach. Expanding faster than light can carry information to us. The cosmic web we observe is not the whole universe. It is only the part whose light has had time to arrive. And inside this vast interconnected structure, the Milky Way is a single thread. The Sun is a bright particle. Earth is a speck in orbit around that particle. And humanity, quiet, hopeful, curious, is a momentary flicker on that speck. The scale of the universe does not merely challenge our understanding. It reshapes it. It reveals a cosmos vast beyond comprehension, structured beyond belief, and beautiful beyond measure. If galaxy clusters are the cities of the universe, superclusters are its continents. Vast land masses of hundreds or thousands of clusters bound loosely together by gravity and expansion. These structures are so expansive that even calling them large feels like a kind of understatement. They are the largest formations in the universe that still remain somewhat gravitationally connected, though even that bond is stretched thin by the accelerating growth of space. Our own home lies within one such structure, the Laniakea Supercluster, a name meaning immense heaven. It spans over 500 million light-years. The Milky Way sits inside a minor tributary of this grand cosmic continent, flowing along gravitational pathways that lead inward toward a region of extraordinary mass known as the Great Attractor. Far from being a single object, the Great Attractor is a gravitational valley, a region where galaxies drift as if pulled by an unseen slope in space-time. But Laniakea is not alone. The universe contains other superclusters of similar or even larger scale: Shapley, Hercules, Coma, Hyperion. Each one is a massive, intricate arrangement of galaxies strung together by filaments that stretch across distances so huge they erase familiar concepts of near and far. Standing at one end of Laniakea and looking toward the opposite boundary would be like trying to see across 500 million stacked galaxies, each containing hundreds of billions of stars, planets, and systems. And yet superclusters are not solid structures. They are tenuous assemblies, delicate and loosely bound. Over unimaginable timescales, many will drift apart as dark energy accelerates the expansion of the universe. What seems unified today may eventually fragment into isolated islands, pulled away from each other by the relentless stretching of space-time. This ephemerality is part of what makes superclusters so astonishing. They are enormous beyond comprehension, and yet they are temporary, cosmic arrangements caught in a delicate balance between gravity pulling inward and expansion pushing outward. They exist at the boundary where matter's desire to cluster meets the universe's desire to drift apart. When we map these superclusters, the Milky Way becomes a tiny fleck within a vast flowing terrain of gravity. Our Sun is smaller still, Earth microscopic, humanity essentially non-existent, and yet for all this, we are capable of seeing the contours of these enormous continents of the cosmos. We stand on a speck of dust and map the architecture of everything. The deeper you travel into the cosmic scale, the more a strange realization begins to form. The universe we see is not the universe that exists. There is a boundary, not a wall, not an edge, but a horizon, beyond which light has not yet had time to reach us. This is the cosmic horizon, the frontier of the observable universe. The observable universe is a sphere centered on Earth, stretching roughly 46 billion light-years in every direction. Not because the universe is 46 billion years old, but because space itself has expanded while light has traveled through it. The result is a visible bubble far larger than the age of the cosmos might suggest. Everything inside this bubble has sent light that has arrived at Earth. Everything outside has not, and may never. Standing inside this sphere is like being in the center of a glowing, expanding shell of ancient light. Every direction you look, you are peering into the past, farther and farther back, until eventually you reach the faint afterglow of the Big Bang itself, the cosmic microwave background, the universe's oldest visible light. It is the silent radiation left behind from a hot, dense beginning, stretched into a faint microwave whisper by billions of years of expansion. But beyond that horizon lies an even greater reality, a universe that continues endlessly, containing galaxies, clusters, superclusters, and voids we will never see. Not because our instruments are inadequate, but because physics itself prevents it. Light from those distant regions will never reach us, not even if we wait an infinite amount of time. Expansion outpaces information. Space grows faster than photons can cross it. This creates a kind of cosmic isolation. We live inside a shrinking island of visibility, surrounded by a vastness we can infer, but never observe. Galaxies that once were visible will drift beyond the horizon. Stars we can see today will disappear from view billions of years from now, sailing over a cosmic waterfall where no information returns. And yet, there is something strangely beautiful about this boundary. The horizon is not a limitation of curiosity, It is a reminder of the universe's immensity. It tells us that our perspective, for all its wonder, is only a tiny window into a far grander cosmos. The universe does not end at the horizon. Our ability to see does. Beyond that invisible boundary lies the rest of reality. At this point, we have crossed every familiar threshold, from planets to stars, stars to galaxies, galaxies to clusters, clusters to superclusters, and onward to the cosmic web and the horizon of the observable universe. And yet, even now, we have not truly captured the scale of all of it. For the universe's size is not just about distance, it is about multiplicity. The Milky Way contains roughly 100 to 400 billion stars. Each of those stars may host planets, moons, asteroids, comets, rings, and countless other structures. Our galaxy is only one of perhaps 2 trillion galaxies in the observable universe. Each of those galaxies contains its own billions or trillions of stars. Most of those stars host worlds. Many host entire families of worlds. Some may have multiple habitable planets. The number of planets alone likely exceeds all the grains of sand on Earth several thousand times over. And that is only the visible universe. Beyond the cosmic horizon lies a region, perhaps infinite in size, containing even more galaxies, more stars, more worlds, more structures we will never witness. The universe may be infinite, or it may simply be far larger than our observable bubble. Either possibility leads to the same conclusion: the cosmos is so vast that human intuition collapses in the face of it. To comprehend this immensity, imagine shrinking the entire observable universe into a sphere the size of Earth. At that scale, the Milky Way would be a microscopic speck. The solar system would be smaller still, invisible to any human eye, and Earth, the home of all human experience, would be an atom suspended inside a single strand of cosmic dust. This is the true scale of the universe. Not simply large, not simply vast, but transcendent in its magnitude. It is a place where human measurements lose meaning. A place where distances cannot be walked, crossed, or even imagined in any familiar way. A place that reminds us how profoundly small we are, and yet how extraordinary it is that we can look out into this immensity and understand even a fraction of it. The universe's size is not meant to intimidate, it is meant to inspire. It shows us that existence is far grander than the confines of our daily lives, that we are part of a cosmos too immense to ever fully comprehend, yet still capable of revealing itself to anyone who dares to ask. As immense as the universe is, our ability to perceive it depends on one fragile messenger: light. Every star, every galaxy, every cluster and filament we observe sends us information carried across unimaginable distances and times. When we gaze into the night sky, we are not seeing the universe as it is. We are seeing it as it was, in some cases, billions of years ago. Light is a time machine, revealing a cosmos frozen at different stages of its own evolution. The Andromeda galaxy we admire today is not the Andromeda that exists now. The photons reaching our telescopes began their journey more than 2 million years ago, when human ancestors first chipped stone tools. The most distant galaxies we've detected are seen as they were when the universe was only a few 100 million years old. Their ancient light has traveled across the growing fabric of space, stretched into red wavelengths like a cosmic echo from the dawn of structure itself. Even the cosmic microwave background, the faint afterglow of the Big Bang, is not a photograph of an explosion. It is a picture of the universe as a hot, foggy plasma more than 13 billion years in the past, before atoms existed, before stars were born, before galaxies took shape. The universe has evolved dramatically since then, but all we can see is the ancient imprint it left behind. This reliance on light creates a fundamental limit to what we can know. No matter how powerful our telescopes become, we are still bound by the speed at which information travels. We cannot see the present universe on large scales. We cannot observe its evolution in real time. We witness only a layered archaeological record, older light arriving from farther distances, younger light from closer regions, all overlapping in a single cosmic panorama. And yet, despite these limits, The universe communicates astonishingly well. Every wavelength carries clues. Radio waves trace cold gas clouds forming new stars. Infrared light reveals hidden galaxies shrouded in dust. X-rays illuminate the violent hearts of galaxy clusters. Gamma rays announce the births of black holes. Gravitational lensing, light bent by mass, maps the presence of dark matter. Our vision may be limited, but it is rich, it is layered, it is powerful. With nothing more than ancient light arriving from the depths of time, we have reconstructed the universe's structure, history, chemistry, and evolution. We are small, but our sight is extraordinary. And every photon we catch is a whisper from somewhere far away, telling the story of a cosmos too vast to ever fully behold. When contemplating the scale of the universe, distance tends to dominate our imagination. But distance alone does not define cosmic immensity. Time is equally vast, so vast it reshapes everything we think we understand about existence. The universe is not static, it is a living, evolving entity, and across cosmic timescales it transforms in ways more dramatic than anything occurring across space. Stars live and die. Galaxies collide and merge. Clusters form, disperse, and reform. Even the cosmic web itself is a dynamic structure, continuously stretched and sculpted by expansion. But these changes unfold not over centuries or millennia, but over millions and billions of years. Human civilization occupies a mere instant in this timeline, an almost invisible flicker. During the Sun's lifetime, the Milky Way has rotated less than one full turn. In the coming billions of years, our galaxy will collide with Andromeda, reshaping its spiral arms into a vast elliptical swarm. The night sky will bloom with new arcs of light as stars from both galaxies intermix, and over time a single giant galaxy will form from the merger. This future is not science fiction, it is cosmic inevitability, written into the trajectories of gravity and time. Farther ahead still, galaxies beyond our local region will drift out of view entirely. Dark energy will accelerate their recession until their light is forever unreachable. The universe will become darker, quieter, and increasingly isolated. Superclusters will fragment, stars will exhaust their fuel, the cosmos will shift from an era of abundance into one of gradual decline. But in the present moment, this precious cosmic sliver, we exist in a uniquely vibrant epoch. Stars are plentiful, galaxies are active, the cosmic web is richly connected, the night sky is full. This window, this era, is temporary on cosmic timescales, but it is ours. We are alive in a universe that is still growing, still shining, still dynamic. Time, then, is the ultimate architect of scale. It transforms tiny quantum fluctuations into sprawling galaxies. It turns hydrogen into complex chemistry, planets, oceans, and life. It molds chaos into structure and structure into evolution. And somewhere along this vast temporal river, a species arose on a quiet blue planet orbiting an ordinary star, one capable of looking into the sky and understanding that time and space are the dual engines of reality. We are the universe contemplating its own history. After traveling across the universe, past the solar system, the stars, the galaxy, the clusters, the superclusters, and the cosmic web itself, we arrive at the inevitable question: what does our place in all of this mean? Confronting the true scale of the universe is not merely an exercise in measurement. It is an encounter with perspective, with humility, and with wonder. We occupy a world that, on cosmic scales, is almost impossibly small. Earth is a speck orbiting a star that is one among hundreds of billions inside a galaxy that is one among trillions. We exist within a visible universe whose radius spans tens of billions of light years, itself likely just one pocket of a far larger and possibly infinite cosmos. And yet, within this immensity, life has emerged, consciousness has formed, a species capable of asking questions about its origins and contemplating the structure of existence has risen from stardust. The universe created us, and now we observe the universe in return. This is the breathtaking paradox of scale. We are insignificant in size, yet extraordinary in awareness. We are tiny, yet capable of understanding immensity. We are temporary, yet capable of uncovering truths that outlive us. The true scale of the universe does not diminish us, it elevates us. It shows that meaning is not measured in size or duration, but in curiosity, in the ability to explore, to learn, and to be awestruck by a cosmos far greater than we can ever fully comprehend. The universe is vast beyond imagination, but the ability to imagine it, that is our gift.